The National Institute of Standards and Technology, known between 1901 and 1988 as the National Bureau of Standards, is a measurement standards laboratory, also known as a National Metrological Institute, which is a non-regulatory agency of the United States Department of Commerce. The Institute's official mission is to promote U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology in ways that enhance economic security and improve our quality of life. NIST had an operating budget for fiscal year 2007 of about $843.3 million. NIST's 2009 budget was $992 million, and it also received $610 million as part of the American Recovery and Reinvestment Act. NIST employs about 2,900 scientists, engineers, technicians, and support and administrative personnel. About 1,800 NIST associates complement the staff. In addition, NIST partners with 1,400 manufacturing specialists and staff at nearly 350 affiliated centers around the country. NIST publishes the Handbook 44 that provides the specifications, tolerances, and other technical requirements for weighing and measuring devices. History. Initial mandate in 1821, John Quincy Adams stated, "Weights and measures may be ranked among the necessities of life to every individual of human society, but this had long been understood." The Articles of Confederation, ratified by the colonies in 1781, contained the clause, "The United States in Congress assembled shall also have the sole and exclusive right and power of regulating the alloy and value of coins struck by their own authority, or by that of the respective states, fixing the standards of weights and measures throughout the United States." Article 1, Section 8 of the Constitution of the United States transferred this power to Congress. The Congress shall have power to coin money, regulate the value thereof, and of foreign coin, and fix the standard of weights and measures. In January 1790, President George Washington, in his first annual message to Congress, stated that uniformity in the currency, weights, and measures of the United States is an object of great importance, and will, I am persuaded, be duly attended to, and ordered Secretary of State Thomas Jefferson to prepare a plan for establishing uniformity in the coinage, weights, and measures of the United States, afterwards referred to as the Jefferson Report. On October 25, 1791, Washington appealed a third time to Congress. A uniformity of the weights and measures of the country is among the important objects submitted to you by the Constitution, and if it can be derived from a standard at once invariable and universal, must be no less honorable to the public council than conducive to the public convenience. But it was not until 1838 that a uniform set of standards was worked out. History. From 1830 until 1901, the role of overseeing weights and measures was carried out by the Office of Standard Weights and Measures, which was part of the U.S. Treasury Department. In 1901, in response to a bill proposed by Congressman James H. Southard, the National Bureau of Standards was founded with the mandate to provide standard weights and measures, and to serve as the National Physical Laboratory for the United States. President Theodore Roosevelt appointed Samuel W. Stratton as the first director. The budget for the first year of operation was $40,000. The Bureau took custody of the copies of the kilogram and meter bars that were the standards for U.S. measures, and set up a program to provide metrology services for United States scientific and commercial users. A laboratory site was constructed in Washington, D.C., and instruments were acquired from the National Physical Laboratories of Europe. In addition to weights and measures, the Bureau developed instruments for electrical units and for measurement of light. In 1905, a meeting was called that would be the first National Conference on Weights and Measures. Initially conceived as purely a metrology agency, The Bureau of Standards was directed by Herbert Hoover to set up divisions to develop commercial standards for materials and products. Page 133. Some of these standards were for products intended for government use, but products standards also affected private sector consumption. Quality standards were developed for products including some types of clothing, automobile brake systems and headlamps, antifreeze, and electrical safety. During World War I, the Bureau worked on multiple problems related to war production, even operating its own facility to produce optical glass when European supplies were cut off. Between the wars, Harry Diamond of the Bureau developed a blind approach radio aircraft landing system. During the Second World War, military research and development was carried out, including development of radio propagation forecast methods, the proximity fuse and the guided bomb. In 1948, financed by the Air Force, the Bureau began design and construction of SEAC, the Standard's Eastern Automatic Computer. The computer went into operation in May 1950 using a combination of vacuum tubes and solid-state diode logic. About the same time, the Standard's Western Automatic Computer was built at the Los Angeles office of the NBS and used for research there. A mobile version, DYSEAC, was built for the Signal Corps in 1954. The National Bureau of Standards became the National Institute of Standards and Technology in 1988. Metric system. The Congress of 1866 legalized the use of the metric system through the passage of U.S. Code 1952 ed. Title 15, ch. 6, sections 204 and 205. On May 20, 1875, 17 out of 20 countries signed a document known as the Metric Convention or the Treaty of the Meter, which established the International Bureau of Weights and Measures under the control of an international committee elected by the General Conference on Weights and Measures Organization. NIST is headquartered in Gaithersburg, Maryland, and operates a facility in Boulder, Colorado. NIST's activities are organized into laboratory programs and extramural programs. Effective October 1, 2010, NIST was realigned by reducing the number of NIST laboratory units from 10 to 6. NIST laboratories include Center for Nanoscale Science and Technology, Engineering Laboratory, Information Technology Laboratory, NIST Center for Neutron Research, Material Measurement Laboratory, Physical Measurement Laboratory. Extramural programs include Hollings Manufacturing Extension Partnership, a nationwide network of centers to assist small and mid-sized manufacturers to create and retain jobs, improve efficiencies, and minimize waste through process improvements and to increase market penetration with innovation and growth strategies. Technology Innovation Program, a grant program where NIST and industry partners cost-share the early-stage development of innovative but high-risk technologies. Baldrige Performance Excellence Program, which administers the Malcolm Baldrige National Quality Award, the nation's highest award for performance and business excellence. NIST's Boulder laboratories are best known for NIST F1, which houses an atomic clock. NIST F1 serves as the source of the nation's official time, from its measurement of the natural resonance frequency of cesium, which defines the second. NIST broadcasts time signals via long-wave radio station, WWVB near Fort Collins, Colorado, and shortwave radio stations WWV and WWVH, located near Fort Collins and Kekauhab, Hawaii, respectively. NIST also operates a neutron science user facility, the NIST Center for Neutron Research. The NCNR provides scientists access to a variety of neutron scattering instruments, which they use in many research fields. The SURF-3 synchrotron ultraviolet radiation facility is a source of synchrotron radiation, in continuous operation since 1961. SURF-3 now serves as the U.S. national standard for source-based radiometry throughout the generalized optical spectrum. All NASA-borne, extreme ultraviolet observation instruments have been calibrated at SURF since the 1970s, and SURF is used for measurement and characterization of systems for extreme ultraviolet lithography. The Center for Nanoscale Science and Technology performs research in nanotechnology, both through internal research efforts and by running a user-accessible cleanroom nanomanufacturing facility. This nanofab is equipped with tools for lithographic patterning and imaging. Committees. NIST has 7 standing committees: Technical Guidelines Development Committee, Advisory Committee on Earthquake Hazards Reduction, National Construction Safety Team Advisory Committee, Information Security and Privacy Advisory Board, Visiting Committee on Advanced Technology, Aldridge National Quality Program Board of Overseers, Manufacturing Extension Partnership National Advisory Board, Projects, Measurements and Standards. As part of its mission, NIST supplies industry, academia, government, and other users with over 1,300 standard reference materials. These artifacts are certified as having specific characteristics or component content, used as calibration standards for measuring equipment and procedures, quality control benchmarks for industrial processes, and experimental control samples. Handbook 44. NIST publishes the Handbook 44 each year after the annual meeting of the National Conference on Weights and Measures. Each edition is developed through cooperation of the Committee on Specifications and Tolerances of the NCWM and the Weights and Measures Division of the NIST. The purpose of the book is a partial fulfillment of the statutory responsibility for cooperation with the states in securing uniformity of weights and measures, laws and methods of inspection. NIST has been publishing various forms of what is now the Handbook 44 since 1918 and began publication under the current name in 1949. The 2010 edition conforms to the concept of the primary use of the SI measurements recommended by the Omnibus Foreign Trade and Competitiveness Act of 1988. Homeland Security. NIST is currently developing government-wide identification card standards for federal employees and contractors to prevent unauthorized persons from gaining access to government buildings and computer systems. World Trade Center collapse investigation. In 2002, the National Construction Safety Team Act mandated NIST to conduct an investigation into the collapse of the World Trade Center Buildings 1 and 2 and the 47-story 7 World Trade Center. The World Trade Center collapse investigation, directed by lead investigator Shyam Sundar, covered 3 aspects, including a technical building and fire safety investigation to study the factors contributing to the probable cause of the collapses of the WTC towers and WTC-7. NIST also established a research and development program to provide the technical basis for improved building and fire codes, standards, and practices, and of dissemination and technical assistance program to engage leaders of the construction and building community in implementing proposed changes to practices, standards, and codes. NIST also is providing practical guidance and tools to better prepare facility owners, contractors, architects, engineers, emergency responders, and regulatory authorities to respond to future disasters. The investigation portion of the response plan was completed with the release of the final report on 7 World Trade Center on November 20, 2008. The final report on the WTC towers, including 30 recommendations for improving building and occupant safety, was released on October 26, 2005. Election technology. NIST works in conjunction with the Technical Guidelines Development Committee of the Election Assistance Commission to develop the voluntary voting system guidelines for voting machines and other election technology. People. 4 scientific researchers at NIST have been awarded Nobel Prizes for work in physics. William D. Phillips in 1997, Eric K. Cornell in 2001, John L. Hall in 2005 and David J. Wineland in 2012, which is the largest number for any U.S. government laboratory. All four were recognized for their work related to laser cooling of atoms, which is directly related to the development and advancement of the atomic clock. In 2011, Dan Shechtman was awarded the Nobel Prize in Chemistry for his work on quasicrystals in the metallurgy division from 1982 to 1984. In addition, John Kahn was awarded the 2011 Kyoto Prize for Materials Science. Other notable people who have worked at NIST include Milton Abramowitz, James S. Albus, Ferdinand Brickweder, Lyman James Briggs, Edgar Buckingham, John W. Kahn, William Koblenz, Ronald Cole, Philip J. Davis, Hugh L. Dryden, Jack Edmonds, Hugo Fano, Charlotte Froese Fisher, Tim Foker, John C. Garand, Douglas Hartree, Magnus Hesteens, Russell A. Kirsch, Cornelius Lanczos, Wilfred Mann, William C. Martin, William Meggers, Christopher Monroe, James G. Nell, Frank W. J. Olver, Ward Plummer, Jacob Rubino, Richard Seychelles, Dan Shechtman, Charlotte Morse Italy, Irene Stegun, Bill Stone, David Wineland. Directors. Since 1989, the director of NIST has been a Schedule C presidential appointee and is confirmed by the United States Senate. And since that year, the average tenure of NIST directors has fallen from 11 years to 2 years in duration. Since the 2011 reorganization of NIST, the director also holds the title of Undersecretary of Commerce for Technology. 15 individuals have officially held the position. They are Samuel W. Stratton, 1901 to 1922, George K. Burgess, 1923 to 1932, Lyman J. Briggs, 1932 to 1945, Edward U. Condon, 1945 to 1951, Alan V. Aston, 1951 to 1969, Lewis M. Branscombe, 1969 to 1972, Richard W. Roberts, 1973 to 1975, Ernest Ambler, 1975 to 1989, John W. Lyons, 1990 to 1993, Arati Prabhakar, 1993 to 1997, Raymond G. Kammer, 1997 to 2000, Karen Brown, 2000-2001, Arden L. Bement, Jr., 2001 to 2004, Rach Semajan, 2004-2005, William Jeffrey, 2005 to 2007, James Turner, 2007-2008, Patrick D. Gallagher, 2008 to 2014, Willie E. May, 2014-present. Controversy. The Guardian and the New York Times reported that NIST allowed the National Security Agency to insert a cryptographically secure pseudorandom number generator called Dual ECDRBG into NIST standard SP800-90 that had a backdoor that the NSA can use to covertly decrypt material that was encrypted using this pseudorandom number generator. Both papers report that the NSA worked covertly to get its own version of SP800-90 approved for worldwide use in 2006. The leaked document states that, eventually, NSA became the sole editor. The reports confirm suspicions and technical grounds publicly raised by cryptographers in 2007 that the ECDRBG could contain an asymmetric backdoor. NIST responded to the allegations, stating that NIST works to publish the strongest cryptographic standards possible, and that it uses a transparent, public process to rigorously vet our recommended standards. The agency stated that there has been some confusion about the standards development process and the role of different organizations in it. The National Security Agency participates in the NIST cryptography process because of its recognized expertise. NIST is also required by statute to consult with the NSA, recognizing the concerns expressed. The agency reopened the public comment period for the SP 800-90 publications, promising that, if vulnerabilities are found in these or any other NIST standards, we will work with the cryptographic community to address them as quickly as possible.